Hello, my name's Desmond Aubrey from RareTech or Rarefied Technologies, Southeast Asia. What I'm going to do today is introduce a new software offering that we've brought out called RTCalc Lite Academic. And the purpose of bringing this out was to actually help university students and academics who want to work with plate heat exchangers at a very affordable price and with a very simple interface. The software that's out there, let's call it business related software, is very expensive and very difficult to use. So with RTCalc Lite Academic, we've come up with a very simple interface, and it's essentially a derivative of the product line we call RTCalc Lite Designer. And this product is very easy to use. We had a case recently where there was a student who wanted a pasteurizer, which is of course quite complicated because there's three parts, there's three exchanges packed into one actually. And so I've used that to do the project for him, and actually was very successful at the end of the day. So it got me thinking that it's something that we need to supply into the market at a very affordable price. So we've actually bundled this product with a few plates. Let me start it up and show you how it operates. I tend to like, certainly when we use Windows 10 and Windows 11, to run as administrator by right clicking. You don't have to, because I've already put it into the shortcut on the desktop anyway, but I just do it out of habit. So we'll start it up, and this is what you'll see. You'll see the splash screen coming up with information on who we are and so on. And if you just walk through the actual screen itself, you've got a main screen here where we can actually launch different modules. And the first module is the single phase heat exchanger. The other one is condenser, so we'll be condensing on one side typically against a liquid on the other side, a cold liquid. Then we have an evaporator. We're evaporating a particular fluid against a hot fluid. Okay, and then pressure drop calculations, and we'll talk through these step by step. So I'll probably put a few videos in the series. And then we have a batch calculation, and then exit, getting you out. And there should be tooltips at various points activated everywhere. So if you put your cursor for long enough over a point, it'll tell you something. And so maybe over the thing it says welcome to RTCalc, enjoy your experience, and so on. And even over labels, it's all over the show. I've put it all over. It's meant to help you when you try to understand something, and try to tell you what you can and can't do. Then that's the main screen. Then we have at the top here, we have various buttons and so on, which some are disabled because they go into the RTCalc Pro series. And I've tried to keep the interface very simple for students. And some of these buttons are useful to use, some are not. Okay, so typically we have at the top here projects and at open calculation, delete, exit. But I actually will show you a simpler way to handle that. Things like settings, properties we talk about, we can adjust fluids, customers, and so on. But for now, a lot of those have been blocked out because they've been that goes to the RTCalc Pro. And then common settings, again, most of that you'll find is blocked out. And then help, there's the about, which we can pull down and have a look at it, and this gives you a little bit about the background. The technology is based on Swedish know-how. It was developed since 1997 as software, actually. Developers from more than 15 countries have participated in this particular technology over time, and it's used as a basis for their own software code by more than 6 major plate exchanger companies. And it's novel, advanced thermofluid performance algorithms. What actually happened is there were people that were pioneers, I call them the plate masters, and they were involved in the foundation actually of a lot of these commercialization of plate exchangers. And then they left a particular company, I won't mention the name, it's a very well-known name, I don't want to get them into trouble. And then they formed a company that we do know called SWEP. This was effectively the first commercialized brazed plate heat exchangers. And they did the development of all the software. In fact, the one guy was one of the founders of this. And then they developed their own code. And after they retired from SWEP or moved on, they actually they continued out in the marketplace. And then a range of companies over the years came to see them and said, well, we need software, please help us. And so that's what actually happened. They then used the source code really the engine part of it, if you want to call it that, to do a lot of the computations. They put maybe a slightly different front end, something like that, but basically the engines have stayed the same all the way from probably the 1960s, to be quite candid with you, with obvious variations over time to adjust to the marketplace and so on. So this is just a bit of background. RTCalc Lite Academic. This is now, as I say, geared for let's call it the chemical engineering and the mechanical engineering faculties of most universities. Alright, and here's a system. If you click this, it'll tell you something about the system you're running on. And then hit the OK button and get out of there. Alright, so that's a bit about the about part. Some of these over here, again, a lot of it I've turned off because they're not totally necessary to you. If you want to change units, you can, but typically I tend to work in SI. There's British, okay, and then there's also typically US who have their own way of doing things. You can change units in the actual calculations, and I'll show you where later. And then they talk about metric units. And some of the other stuff I've actually just turned off. And then there was also a way, if you go to RTCalc Pro, where you can actually change the form of the report. But I've locked it in at HTML here for this particular version that's come out, to keep it simple. And you can also tag the different types of exchanges, these over here, but from these buttons if you want to. And there's a thing called multi-calc, which is not operational at this in this version, but it's something where you can do batch of real range of calculations all at once. And then we go over to here, to this part here, where we have projects and settings. And if you double click, slows down a bit sometimes in this, I'm running it on a virtual machine, so you double click and it opens up to a range of different tabs. So you have the standard examples, calibration, designs, and then a whole range of different plate types stuck out here for you to play with, parametric studies and experimental. Now if you go through, we'll just talk through this now in the second part. Sorry, it's a little bit slouchy today. Alright, this is my virtual machine that I'm running it on. So under standard examples, we're sitting with batch, condenser, evaporator, pressure drop, and plate exchanger examples. So if you want to now open those up, you just click on the plus. I don't know why it's so slouchy today. And then basically you go in and you can select different examples. So we might want to look and say, okay, the batch, we do the beer cooling example. And so there's information here about what is batch all about. Normally there's something in there. And it'll tell you something, various batch calculations. But for some specific stuff, I've actually put a lot of detail in there as well. Okay. And then if you go on to parameters, that's where you click and activate. So if you click that, it'll actually launch a screen for you, a batch calculation with data already input for you. So for instance, you'll have beer on the one side and water on the other side. Okay, and you've got beer in a tank. You know, let's say the tank starts off at 90 degrees and you want to drop it to 50 degrees. You've got a batch size of so many kilogram. In this case, we've selected, these are the units that you can work with. So kilogram, in this case Celsius, you can play with these as well. You can adjust these as a pull down. You can adjust them if you're wanting to go to another unit. But this at the moment sitting in SI, I prefer to work there. So these are the units. So you've got batch temperature of this beer from 90 to 50, just an example. Batch size of 1,000 kilograms, so roughly 1,000 liters. And you've got a certain mass flow rate that's going to come out of this tank, go through a plate heat exchanger, circulate, and go back into the tank. And you want to eventually cool that whole batch from 90 to 50. And what you're trying to determine is what should the parameters be for your design of your heat exchanger. And you're giving yourself 3,600 seconds to do it. And what you've got to do the cooling is water at 25 degrees and a flow rate of, let's say, 1 kilogram a second. We're running very low. We can actually change this also to kilograms an hour, and you can go to, that's in the normal SR systems, or you can go to the British units or whatever you want to do. And then you go and you hit the calculate button and it'll populate, boom, with information. So it's saying to you, when you design your plate exchanger, you're going to design it as though it had beer coming in at 70 and coming out at 58.06. And what you're then saying is that my cooling water will come in at 25 and my outlet temperature of 36.63. and then you're going to use a heat capacity of a specific heat here, and a number of heat transfer units, NTU, if you want to work with it. So what it's telling you, this here is your design parameters. These are design parameters you put into your process specification sheet. Okay, so when you actually spec the heat exchanger, or you go to the manufacturer and say, okay, I want a heat exchanger there, and you as a process engineer know this and that available to you, this is the exchanger that you must design to. And a lot of process engineers actually don't know, a lot of heat exchanger designers don't even know all this. This is now a process engineer's forte. And you then go ahead and you spec that out. Now, you've now done the calculation, and then you go out and you can pump out a report of that. Generate output report, and it'll give you an HTML report. And there's a logo, and it's actually got academic versions stuck on here so that we keep it legal and everything's fine. And so we know that you're not going to go out and sell product or something, or go and sell designs to a client or something. You're just using it for university study purposes. All right. So you've got the two different sides to the plate heat exchanger. Beer on the one side, water on the other. Giving you the properties, the specific heat capacity. Some countries just call it heat capacity. All right. Batch size that you're working on. Initial batch temperature of this, outlet that, inlet temperature of that. So in other words, this is your batch itself. But your designer is actually going to, the plate exchanger designer is going to say, all right, I'm now treating it as though my beer was at 70 and coming out at 58.06, because that actually, given that time, will actually drop that beer on average. It starts off being over efficient and it drops down to being under efficient, but over the time of that 3,600 seconds it'll eventually cool. Given this exchanger design, it will cool that batch for you. Alright, and that's using cooling water at 25 and going out at that. And again, heat transfer units put in there, and you can actually print this thing out. You can, if you go, I've left it in HTML to keep it simple. RTCalc Pro allows you to actually print it out to Word as well if you want to. So in this case, you just dump it to print, and you say, all right, I'm going to print it through the Windows system, and off it goes. And you can actually even save it as a file if you want to. You can print it somewhere. It says, where do you want to print it? And you say, I want to print it to a file. So you can dump it to a file if you like, and that's what I've done here. So you save it as a PDF, and you can then grab it. Some programs will allow you then to convert, if you want to really play with it a bit more for your reports and so on. You can then dump it into you can extract it into Word or something else from HTML. It's not difficult. Under Linux is very easy. I run most of my systems on Linux, but this particular program we're running under Windows, that's why it's in a virtual machine, and most of the market still runs under Windows. But for all my computing, number crunching at the back, I typically use Linux, which has a lot more utilities. Alright, so that gives you a bit of an explanation, just a little bit, about how easy it is to start playing with these standard examples. So that's the batch. And then if we want to get if you wanted to save as some other name, you can actually hit the save as button, but I won't do that right now, but you can if you want to. Or you could start again and have a new application completely. And in other words, you get out of there, you want to finish. If you went in directly to batch and you hit this button, you'd be presented with a blank screen, a blank input screen. So you've got to then pump all the information into there. So that's quite a lot of work, and you're messing around backwards and forwards, seeing if you're right or wrong or whatever. But that's why it's a lot easier. I've given you all these, let's call them canned examples, and bang, you've got some data to start playing with. So it makes it a lot easier for a novice or for someone who really wants to get on the fast track to get on with it without trying to reinvent the wheel. It's quite scary when you present it with a blank sheet and you don't know if you're going to make a mistake or not. Now the tooltips here should activate. Gives you batch size, for instance. It talk about batch initial temperature, final temperature of the batch. Should come up. Sometimes it does or doesn't. There it is. The type of fluid you can select. You can actually then go in if you want to, and you can change it from beer. You might say, I want to do coconut oil. Let's see if it does anything. Alright, coconut oil. And some values will probably change. And then we go and we hit the calculate, and off it goes. It should give me the answers. There they are. And they are slightly different. Okay, the heat capacity is totally different. So it's actually going to affect your exchange, and you notice the temperatures will mess around as well and so on. Those are a function of your streams. But the actual design of the exchanger, when you get to it, in other words, this would be a single phase exchanger. You'll find it's very different because you're using coconut oil. It's an oil base, and it's very poor on heat transfer coefficient. You actually can see here the heat capacity is literally half of that of water. So it's problematic. And typically also you tend to go into a low Reynolds number, as we call it. But I won't go into all those details right now. But you can play. So you can actually change it. You know, you can have coconut oil, whatever you like. You can put cream in there if you really want to. All right, I wouldn't go 90 cream. But anyway, you can. And you can then calculate again and see if it gives you something useful. And those are now the input parameters to the plate exchanger part, which you will do later under PHE as a designer. You take all those values, print it out, have a look at it, and it's okay, pump it in to my PHE design. Okay, so what I'll do, I'll stop there with this part of the, and I'll actually relaunch it again and continue later with further things like the condenser, evaporator, pressure drop, PHE. You just walk you through it a little bit. I don't want to make it too long as a video. Alright, so we'll stop at that point. I'll come back to it, relaunch it on the second recording. Thanks very much for watching. I haven't bored you. I'll try to keep it nice and short. Okay, bye-bye for now.